Hello and welcome back. Thanks for clicking on this next Unargeable One production. Today we're going to talk about a little bit of statistics and how they relate to linear functions by talking about scatter plots and lines of best fit. All right, so let's get started. Okay, so the first thing we're going to talk about is a scatter plot. All you need to know about a scatter plot is that a scatter plot is simply a graph of plotted points that show the relationship between two sets of data. So over here on the right, you could imagine going around the classroom and surveying your fellow students or classmates about what their height is and what their weight is. And then if you were to take all of these data points that you get for each person and plot them, you would create what we call a scatter plot. So each one of these points represents someone's height and weight. Okay? Now, what you can see is that the relationship between their height and their weight, it's not linear, right? I mean, linear it would just be a straight line. Okay? So literally everybody's height and weight would go straight up like that. Now that's not how the world works, right? That's not how people work. Okay? So it's not going to be linear. However, there is a trend or what we would call a correlation to people's weight and height. It certainly looks like, okay, the less people weigh, the shorter they are, right? It certainly looks like as your weight goes up, your height goes up, okay? That is called a correlation, which is what we're going to look at on our next slide. But this right here is just a scatter plot. Okay, so a correlation is the relationship between two variables in a scatter plot. The stronger the correlation, the closer the points are together, okay, the closer they are to making, in this case, a line. The weaker the correlation, the further apart they are. All right, so there's two types of correlations that we have to talk about. The first one is a positive correlation. So a positive correlation means the relationship between the two variables, x and y, they both increase. They're both going up. As x goes up, y goes up, okay? If you try to draw what would be like a line in here somewhere, okay, as best you can, your line, this is called a line of best fit, which we'll talk about in a few minutes, has a positive slope, right? Positive slope for positive correlation. So a good example of a positive correlation would be, let's say, a baseball or softball player, their number of at-bats, okay, versus their number of hits, all right, number of base hits, okay, right? Theoretically, the more at-bats they get, the more hits they'll get, all right? As their number of at-bats go up, their number of hits go up, okay? So there would be an example of what a positive correlation might look like. All right, that's our first type of correlation. And then the next one is, of course, a negative correlation. So a negative correlation means one of the variables increases and the other decreases. So you can see here, again, if I kind of draw my line through the data, my line of best fit, which we'll call it in a few minutes, like I said, the slope is a negative slope. Okay, this slope is a negative. All right, the x values go up, but the y values come down. Okay, the further along on the x-axis you get, the lower you get on the y-axis. So a good example of this would be, let's say you owe somebody some money and you pay them back, okay, or you have a car loan. All right, so let's say this is the number of months on the x-axis and the amount owed on the y-axis, money. Okay, so if you're paying off that car loan, right, as the number of months go on, the amount that you owe decreases. Okay, so the more months you pay, the less money you owe. So that's an example of a negative correlation. All right. Now the third type of correlation, which isn't really a correlation, but we have to talk about it, it's no correlation. Okay, so no correlation means that the two variables aren't related to each other at all. All right, like for example, the number of ice cream cones you eat per month and the number of video games that you have in your home. you would look at me if I said, what's the relationship between those two? You would be like, what? There's no relationship between those? You're right, there is no relationship between those. So we say there's no correlation. Okay? All right, so let's take a look real quick. And here's the 3 scatter plots, and I want to know if they have a positive, negative, or no correlation. Okay, you can do them for yourself real quick here, but I'll do them with you. So this first one, if I kind of draw my line in, the line has a negative slope, so this is a negative correlation. Okay, x goes up, y goes down. The second one, if I draw my line through, it has a positive correlation, right? As x goes up, y goes up. And in the third one, this is a good example of there's no correlation at all. Okay, it doesn't look like the points are increasing, and it doesn't look like the points are decreasing either. They're just kind of scattered all over the place. So we would say that has no correlation. All right, now it's your turn. And here's another one. Okay, no association means no correlation. So which of these has no correlation? Okay, now back to a scatter plot. So a scatter plot is a graph that shows a set of data and has 2 variables. So here is a chart. Okay, let's say there was a survey done, and here's the amount of time that people spent studying, we'll say in minutes, and then their test score. Okay, so theoretically, the more time you study, the higher your score should be, right? So here is the data that we just plotted. Okay, these are just data points from this chart. All right, data points from the chart. Now we can certainly see that it looks like the line or the data has a positive correlation, right? Meaning the more time you study, the higher your grade. Okay, so let's talk about how we can draw our line in with a line of best fit. So let's talk about the line of best fit. So what you see drawn here through the data is called a line of best fit. Okay, to draw your line of best fit, you want to try to draw the line, all right, as close to the data as possible. Okay, you want to try to have the same number of points above the line as you do below the line. Okay, and if you can, you want to try to draw it through 2 points because then you can write the equation of that line. All right, so for example, if you look here, we have this 1 point here is above the line, 2, 3 points above the line, and then we also have 1, 2, 3 points below the line, and it looks like we have 2 points that are right on the line. 1, 2. Now, if we know these 2 points, we could write the equation of the line, right? 35, 82 is 1 point, and 50, 90 is my other point. And again, these points come from the chart that's in the previous slide, right, where we graphed our data. Okay, this is the same graph that was on the last slide. So we can write the equation of this line. We need to find the slope. So it's delta y over delta x. So that's going to be 90 minus 82 over 50 minus 35, which is going to be 8 over 15. And then we could write the equation of the line if we wanted to. We could do it in point slope form. That's probably the easiest. So y minus 90 is equal to 8 over 15, x minus 50. So there's my equation. I use this point. You could also use the other point, right? It doesn't matter. All right. You could even put it in slope-intercept form if you wanted to. You'd have to solve it for y. Okay. But here is your line of best fit, the equation for the line of best fit. All right. So that's what we're asking you to do here. Okay. Draw in a line. All right. That best fits the data. Hence, line of best fit. Okay. So here's an example. So here's another example of a study being done to hours studied and the test score that you got. So here are all the data points. Okay, I actually graphed them here, all right, on this chart or on the coordinate plane already. And now what I want to do is I want to draw in my line of best fit. So you can get a pretty good idea here. It kind of looks like the line should go right down the middle, right? And that would be really good if it does. All right, so that would be our best bet. And if we did that, we drew our line in like this, we'd have 4 points above it and 4 points below it. And again, we do our best to have the same number of points above it and the same number of points below it. There's no guarantee, but we do our best. So here's my line of best fit, right? So now I want to write the equation for the line of best fit. That's what this question says. Write the equation for the line of best fit. Okay, so we have a point here on our graph. This point is 0, 20. Okay, I got it right off the chart here. And then this other point that's here is the one that's at 580. I know it's a little hard to see the numbers, but that's the one it is. All right, so we have 0, 20 is one point, and 580 is our other point. So we can write the equation of the line. We need to find the slope. So that's delta y over delta x. So that's going to be 80 minus 20 over 5 minus 0. So that's 60 over 5. That's going to be 12. So my slope is 12. And now, in this case, I can actually write it in either form pretty easily, right? If I want to write it in point slope form, I could do y minus 80 equals 12, x minus 5. But I could also write it in slope-intercept form as well pretty easily because that's the y-intercept, the 0, 20. So I could write y equals 12x plus 20. Okay? And if I wanted to, I could solve this point-slope form equation, and it would also then be written in slope-intercept form. I should get the same answer. Minus 60, add the 80 on both sides, and sure enough, you get the slope-intercept form, which is y equals 12x plus 20. So there's my equation, y equals 12x plus 20. All right, so we're going to use this on the next slide, okay, to answer some questions. All right, now you have to remember also that x is hours studied and y is the test score. Okay, you can also see that this has a positive correlation, right? As your hours study go up, your test score goes up. All right, so we got y equals 12x plus 20. Here we go. All right, so let's come up here real quick. My line is y equals 12x plus 20. X is the number of hours, and y is the score, okay, test score. All right, so now they say using your line of best fit, predict what score you would get if you studied for 8 hours. So now this isn't actually what you'd get if you studied for 8 hours. You're just using the line to take a guess. Okay, so we got 12x plus 20, that's our line. X is going to be 8 hours. Let's put it in. So we have y equals 12 times 8 plus 20. So y equals 96 plus 20. So apparently you're going to get 116 on your test if you study for 8 hours. That's really good, but probably also not possible. Okay? So again, your line of best fit is just predicting what you'll get. It's not actually what you're going to get. All right, so letter C says if someone earned a 70 on their test, predict how long they studied for. So that means the y is now 70. So we know y equals 12x plus 20. So 70 equals 12x plus 20. So let's come over here. We're going to subtract 20 on both sides. We've got to solve for x. We have 50 equals 12x and divide by 12. And you get x equals 50 over 12, which is 4 and 1/6. Okay, 4 1/6. 4 1/6 hours is what you studied for. All right. So letter D says, what is the y-intercept and what does it represent? Okay, well, we know the y-intercept. It's right here on the line. Here it is. It's 20. Okay, 0, 20. What does it mean? If you don't study, you are predicted to get a 20 on the test. Okay? Again, it's a prediction. It doesn't mean you're going to get a 20. All right? But it's a prediction that you'll get a 20. Okay? And then letter E, would it be possible for someone to get 100% on the test and not study? Well, of course it is. I mean, I'm sure you folks have done it before. Okay, gotten 100, didn't study at all. All right? And then explain why this doesn't match the representation of your line of best fit. But what did we say about the line? We keep saying it over and over, right? It's a prediction. It's just predicting what you're going to get. It's not what you're actually going to get. Okay? It's just predicting what you're going to get. All right? So that would be your answer for letter E. Okay? All right, so let's keep going here. And it's your turn. Oops. Hang on one second. I got to go back. There you go. All right, now it's your turn. Okay, and here, just to be clear, the question is, which 2 points should you draw the line of best fit through to give you the best line possible? Okay, which 2 points should you draw the line of best fit through to give you the best line of best fit? And here's one more finally. And after that, you're all done. And as always, thanks for clicking.